In this short video, we'll go further with the foundation services Timeout Driver, looking at the one-shot code snippet as a context. So this was the situation at the end of the first video on the Timeout Driver, looking at the periodic timer. So we're just going to refactor the data visualizer setup here to make it a little cleaner. So we'll add GPIO 0 on the bottom plot. And note that according to the kit and the schematics here, that GPIO 0 is the switch and GPIO 1 is the LED. So what we'd like to do is now start a one-shot timer when we push the button. We'd like an interrupt for that, so going to the pin manager and the pin module, we just need to set a falling edge here since the button is active low. Then in the timeout driver, generate a one-shot example. Okay, so if we make some changes, sometimes you want to force update on all, and then you'll get this diff window. We're going to accept all the changes in the timeout example, but leave those in main. Okay, so what we're going to do now is have a look at what has been generated in the timeout example. So let's put that next to main. The main difference is that the one-shot timer, it's just returns 0, so the timer is not rescheduled, whereas here we have a 1000 tick timer, and remember that those ticks were set by the clock source for the module that the timeout runs on, which was the RTC. So let's replace what is in main with this example code here instead. So we're going to cut so that we don't have duplicate functions in our code and replace that in main. So we have the one-shot handler, create scheduler mode. The scheduler mode is one of the two modes of the timer. Remember that we have a scheduler and a stopwatch mode, and whether or not it's a one-shot timer is just dependent on whether it's rescheduled. So we have the same function here. Now what we want to do is start the timer on a button press, and we set an interrupt for that. So under source, pinmanager.c, and at the end of this file, we'll find the interrupt service routine, which handles any of the interrupts that we've set up. And here you will find a default interrupt handler for the switch. So I'm going to put this in main, roundabout where the action is happening with my timers. So what we'd like to do is start this timer, as in timeout create, in the callback. So if we do this here and we try compile, we'll get a complaint now. One-shot timer is undeclared, and the timer itself is the timer struct. This defines an instance of the timer. So the scope of the timer is the scope of the timer struct. So we can move this out of the timeout example, and then you can see that all we're doing here now is just rescheduling the next callback. So let's put that in the while loop in main, and now we don't actually do anything in here. So we'll delete that and remember to remove it here. So what we want to do is, as we push the button, we want to set our LED high. So we have that Debug GPIO 0, which was connected to the LED. So we want to set high, which is the start of our timer. And then as our timer times out, we'll put the set low here. And let's program again. And now as we trigger a one-shot timer, we can see that it runs for about a second and then stops. And if we keep triggering a timeout, note that it will keep being rescheduled until we allow it to complete. This behavior is expected. If we click on Timeout Create, we can see that the function adds to the queue. If the timer was already active, it will be replaced by this, and the old active timer will be removed or cancelled. In the next video, we'll go on further and have a look at sending payloads to the Timeout Driver.